Hello everyone and welcome back. So I've been building this environment using Houdini and Unreal Engine, as you can see. And in today's video I wanted to show you how you can build this particular asset here, this designer table, let's say. And if you would like to see more content like this, please let me know in the comments. Maybe you want to know how I modeled this table, how I modeled and simulated this couch or this chair. So let me know in the comments. Okay, let's get started. So let's start by dropping a geometry container, and we will start with a flat plane so we can deform it later. So let's start with a grid that is 10 by 1 and 2 columns, 2 rows and 32 columns, and we want to change it to alternating triangles so we have that typical remeshed look. Now we will start to copy this shape since we want several levels. So let's copy by the bounding box size, the size. So we will just offset by the size of the initial shape. And now we want to scale it to 0.3. And as you can see, it's not scaling from that particular spot where we meet the two shapes, but actually from the center, as you can see. So what we can do is go into the pivot transform, copy this expression and paste on the Z min, and now it will scale from that particular spot. Now we want to output the groups, so we have copy group 1, copy group 0 and 1, and let's do another copy. We can just copy this one, but this time call it copy group B, and let's not scale it, and let's see our groups. Let's try to disconnect it. Yeah, sometimes the groups get messed up, but now it's working. So let's combine the groups so we can blast this last shape that we don't want. So we'll name it last, and we will combine copy group B1 and subtract copy group 0. So we get this shape in here, so we can just blast the group. Now we want to create a name attribute for each row we have here. So for that I'm going to use a group combine again, and I already have this set up, but basically I'm gonna say level A is going to be equal to copy group B0, and we will subtract it with copy group 1. So let's see if that works. Copy group 1, no, not copy group 0, but actually copy group B0. So this will be a level 1, and we want to add another one, call it level B, and will be equals to copy group 1, and we will have another one, level C, and will be equal to copy group 0 subtracted by copy group B0. So let's see our groups now. Let's do a group delete, and let's delete everything everything that is not level. Does this work? Not really. So this doesn't seem to work. Let me see. Level is not a valid group, so let's do this and this. This deletes the levels. Oops. Delete unused groups. Let's see. Does this work? No. So it actually needs to be separated by a space. So if we do all but the level groups, it should work. I didn't test this before, sorry about that. So now let's create a name from groups, and we will do level, and let's check it, and indeed we have the name attributes. So now we want to do a few things. First of all, let's create a loop. So for each named primitive, and we will iterate over each level. And the first thing we need to do is to delete these middle edges. Since we don't want them, it will not mimic the correct shape. So let's do a group range and select every other primitive, and this will indeed select our triangles. So now we can group promote and group promote the group one to edges, and let's do this one, and don't include unshared edges. Now we want to create a group for the unshared edges, so edges, and let's group combine again. This is a masterclass on group combine. And let's do edges, and we group one, and let's union with the unshared. So now we have everything but those edges that we want to delete. So what we can do now is do dissolve, and we will dissolve the edges, and we will dissolve non-selected. So we got rid of those extra edges. Now we want to do we want to deform this shape to a cylinder, to look like a cylinder. So for that we will use the pet deform, and we will use a circle. So let's create a circle, and we want it in the ZX plane. Let's give it a few subdivisions and say we want to open arc. Okay. After that, let's connect it here and see the result. So this node is a bit tricky to work with. So what we want to do first is to find the correct axis, and in this case we want X and Z. So still looking a bit off. What we need to do is to use fraction of the curve length, and now it should work fine. We could possibly resample, but let's leave it like that for now. So now we still, let's do this flat shading. Now we still have this edge here that is not deforming the shape correctly. As you can see, it's creating this pattern, and we want a flat one. So what we can do is use a fuse, and we will fuse, we will not fuse the points but output the snapped points. So as you can see, if we go to points, we have this group in here that now we can promote, group promote to edges. So snapped points to edges, and include only elements in the boundary. And we can now fuse everything now for real and dissolve that particular edge. So snap points. Okay. Alright, let's see how this is looking. So we have all the shapes necessary, but they are all on top of each other, which we need to fix somehow. So this is actually pretty simple. We just need to match size, and we will duplicate these inputs by alt dragging and say fetch feedback so we can access the previous iteration. And let's match size with the last iteration, and we will do min and max. And this should give us the shapes correctly. Let's see, let's add a normal, and we set it to where this is, but and remove the name attribute, the visualization. We might want to reverse the patches, so let's just see if we have an option in here, and yes, we have reverse curve. So now since they have the triangles in the same position, we need to offset each shape a bit. So for that we will use a transform. So let's use a transform, and we will rotate the shape. And first of all, we need to rotate, let's see, if we rotate in Y, it's not rotating from the center. Oh, in the match size we need to set this to none. So now it's rotating from the center. So how much do we need to rotate? So we will take the grid columns which created this initial pattern. So let's copy this parameter and let's divide 360, which is a full circle, by the, oops, I didn't copy it, I need to paste relative reference. So grid calls. So now just rotates everything. Since I don't want to rotate the first one, which is the iteration 0, I can use the detail attributes on this loop. So at in the second level it will rotate one time and then two. So what we can do is create the metadata node. Oops. Let's drag it here and add it a spare input, and we will just multiply these. So let me see. We need to multiply these by the detail -1, which is a spare input, iteration 0. So we also need to remove 1 from here. So we need parentheses here and do -1. Yeah, that works. And multiplied by, oops. Yeah, that works. Divide 360 by the columns and multiply it with the iteration. And now we have everything working, as you can see. Alright, so now we want to give it a tapering effect, but kind of mirrored. So let's use a linear taper, which is just a bend node, but with a taper preset. And let's see. Let's press enter on the viewport and press B. And let's just taper. So it's working right now. And we don't actually want a taper, but instead do a squish. And take the pivot. We can play with the pivot, but we will enable ramp, choose B-spline, and do something like this. And create another point in here, so we can actually taper it a bit more. And we can play with the pivot. So something like this, and maybe play with the capture length. So let me check my original file, but you get the idea. So actually I have this in 1, and let's change this to 1, change this to 0. So something like this. And now our geometry is not connected, so let's add a fuse. And a normal. We can just copy from here, so we can visualize it better. And now let's fill the caps. So fill, polyfill. And fill it with a triangle fan, and let's do a bevel to finish it off. .1 is too much. Let me see how much I used. 0.015, and let's do 3. Now we can do a soften normals. So that's our final shape. Hopefully you'll learn a few techniques along the way. It's not too complex, but I don't see it being modeled otherwise. It will be quite hard to be this precise, so yeah, Houdini saves the day. And again, if you want to see anything else modeled that you can see in this work in progress, I can definitely do another tutorial covering that. So that's about it. Thank you, grab the file on Patreon, and I'll see you next time. Bye.